Welcome to CTC 114, Wet Laboratory Techniques. And in this lecture, we're going to learn about the analytical balance. Yeah, I know, this is pretty simple, straightforward things, especially if you've had a science course before, right? I mean, who's never used an analytical balance? But the problem here is that we are making the assumption that not everyone has had a science course before, and maybe they did not use an analytical balance before. And even if they have used a balance, how do we know that they've used an analytical balance and not another type of balance instead, which might be pretty commonplace in middle school or high school laboratories? So again, we think of these classes, no science background required, no prerequisites required. You can come to us, sign up for the course, and we take you. That's what we do. So we never take things for granted. And this lecture is especially for those students because they are not forgotten. And even if you have worked with analytical balances, there is a chance that you might not know some of the information that I'm getting ready to present. So not only do we cover the people that have no experience at all, but we're also going to give you little golden nuggets of information if you have used the analytical balance. All right, so analytical balance, pretty important, very common tool in a laboratory, and we're going to have to get used to it, and that's why we start with the analytical balance in the very beginning of the semester almost every single time. Now, with that said, one of the balances that I want you to stay away from is a nasty, skanky, cheap, little, awful balance. Don't get near this, please. Don't be using this in a laboratory. Look at this. You get what you pay for, folks. $15.99. $15.99 ordered directly from Amazon, shipped to your home, and installed in your kitchen. I mean, it's great for that purpose, right? If you're measuring out flour, measuring out sugar, because in the baking world, maybe you do things by mass instead of by volume. Now, that's perfectly okay for your kitchen. Buy the $15.99 balance. But folks, this is not good for a laboratory environment, especially with what we need in our laboratory facilities and what industry needs for their laboratory facilities. So you will never see us have balances that are like this. This actually isn't even called an analytical balance. This is what we would maybe more properly refer to as a top-loading balance instead. Why do they call it a top-loading balance? Because you put things on top of the pan and you weigh it, right? Well, not necessarily, because analytical balances are used that way too, but a top-loader balance is really kind of the layman term that we use for these types of balances when we see them. So once again, they are cheap, they are trashy, they are skanky. You stay away from them. You don't want anything to do with them because there's much better things that we need in our laboratory facility that's going to allow us to do our job the proper way. Now, where else would you find these? Well, if not in your kitchen, you might find these maybe in elementary schools, middle schools, high schools, large part of academics. This is what they really like because they are cheap. And it kind of suits the purpose. And what those classrooms actually do doesn't necessarily need exact measurements, but it gets them close enough. So there are purposes of those types of balances. You're just not going to find them in the chemical technology laboratory spaces. And you're not going to find them in industry either. Sorry, you're just not. So if you take a look at this particular balance, here on the digital readout, you're seeing a number, and that number goes to 1 decimal place, right? So this is a very kind of big giveaway that this is not a prim and proper analytical balance, because what we would need in a lab environment would need to go more than that 1 decimal place. So that 1 decimal place, that's called the 10th, right? The tenths. If you go back and revisit math, great, we all love math, right? Yay. All right, so that 1 decimal place is the 10th measurement. We need to go further than that, folks, in order to do our job and do our measurements accordingly. There are top loader balances. Instead of 1 decimal place, they'll go to 2 decimal places, and that is what we call the hundredths. So the tenths or the hundredths of a gram, that is not very good for what we need. We need to go a little bit further. All right, so those are top loader balances. Again, very cheap. You get what you pay for. They are appropriate in some cases, in some environments, but you will never find these in a working laboratory at all. Sorry, you're just not going to do it. Instead, what you're going to find is a prim and proper analytical balance. And then if you look at this, cha-ching, 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 $3,000 a pop, if not more. So from the very get-go, I just went on this spiel about decimal places. Look at this decimal place here on that readout. That goes to 4 digits, right? So we are getting a little bit more kind of honed in on the true number, and we're a little bit more sensitive, a little bit more accurate, and that goes to 4 decimal places, which is greater than a milligram, right? A milligram would be 3 digits. This goes to 4. So these balances are way more expensive because they are more precise, and they're going to be better as far as measuring accurate numbers that we can write down in a laboratory space. Now, granted, not everyone has $3,000 per balance, and that's understandable, but to do what we need to do in a laboratory and in industry, these are going to have to be a requirement. All right. So if you take a look at our laboratory spaces, we currently have actually 14 of these that is located in our main laboratory and the adjacent prep room and laboratory beside of that. So we've got about $42,000 to $45,000 that's invested in just analytical balances alone. Now, these are more expensive. They're a little fancier, but they can actually go more expensive than this. And they can go fancier than this. These things are great for college labs. These things are great for some employers. But sometimes, depending on where you work, you need to go even better than this. And now, can you imagine what that price tag is going to be, right? So for these particular analytical balances, you're going to see that these balances are going to measure 3 decimal places, or you're going to see that these balances will measure 4 decimal places most of the time. We prefer the 4 ones. All right. When we have analytical balances that we like to order, we like to go to 4 digits after the decimal point. And there are, though, some balances in our lab that stop at 3. And these were actually a mistake. Oh, this was a mistake on my part. Because when I had quoted balances for the college to order, I actually wrote down accidentally the wrong item number when I sent that order through. And the way that the college works, we ordered it, that particular amount was approved, and we received them. When we realized that only 3 digits were there instead of 4, we could have sent them back, but we would have lost out on that money. We were not able to order different balances because those were a little bit more expensive, and that is not what the college approved. So because of that, we would have forfeited our order. So we took those balances. They do a pretty good job. We're not going to complain about them. I'll just nag about them a little bit. But 4 decimal places is what we really like. But you will find 3 in our laboratory, and that's okay. All right, so the 4 decimal places, that is to the 10,000ths, right? All right, so I want to go up here in the very corner, and I just want to remind you, 1 gram is equal to 1,000 milligrams. So we're going to need that reference a little bit later. We're going to be using that reference and that conversion factor a little bit for what we do throughout this semester. And that's something that I would just say, just go ahead and memorize it. I don't like the word memorize, but just go ahead and memorize it. Kind of get that down pat. 1 gram is 1,000 milligrams. That way we can go from one unit to the next. All right. Okay, so with that said, this is what you're going to be working with. This is what you're going to see in our lab spaces. This is what's going to be important as far as taking measurements and taking masses throughout the time that you are with us. Now, these balances, like I said before, can actually go more expensive. They can go fancier. Ta-da! So here we have a balance that actually still goes to 4 decimal places. Look at this display screen, 0.0000 gram. All right, so as far as the readability or the precision or the accuracy of this thing, it's about the same as the analytical balance. The difference is that this balance, just like the other one, has what we call this draft shield. That's the proper term for these things. Draft shields, which are this encasement of glass around the top of the balance pan. And these are kind of like the grocery store doors, where you walk up to the grocery store and then, the doors just open up. And that's what happens here with the analytical balance. So I go over to the balance, and the balance knows that I'm there. There's a sensor on it, and the doors open up for me, and then I can have access to the inside where the balance pan is at, and then I weigh out what I need to weigh out, and then I kind of step away from it, my hands at least go away from it, and then the doors will close. So that's the number one thing, at least the first thing, that I want to talk to you about now. And that is when you use these analytical balances, and this really is what we have in our lab, there are doors on the side that slide back and forth. When you measure something on this balance, properly, these doors should be shut. In addition to that, there's also a door at the top. So that way we can have access to the balance area that way as well. So make sure that those doors are completely shut before you write down the mass measurement that you see on the display readout of the analytical balance. All doors, tops, left, and the right. Okay, so we don't really need this kind of thing in our lab. No one's going to be spending $10,500 on a balance pan that will just automatically open up for me. That is a waste of taxpayer dollars, because that's how we get our money for our budgets. It's through the wonderful taxpayers of North Carolina. So thank you for your investment. We appreciate it. And I'm not going to waste your money on buying things like this that's not necessarily needed. Okay? All right, so there's one type of upgrade that we can talk about. Automatic doors will happen with these balances. Kind of differences here. I know I've been saying top loader, top loader, top loader, top loader. But in the analytical world and proper laboratory world, those top loader balances are sometimes just called precision. So a precision balance, ooh, makes me feel really good. Makes me sound like I'm getting something that's worth my money. Precision balances. That's just another word for a top loader most of the time. So what you're going to see is that these precision balances, or these top loader balances, these are great if the gram amount that you're trying to weigh out is really, really big. So we're talking like 400 grams, 500 grams, 1,000 grams, a kilogram of stuff. Those are really good for those purposes, and there's a place for that. So I want you to think like maybe a vet clinic. Okay, so let's say that you go to the vet and you take your dog or your cat and they put them on the balance. That's what they do, right? So they put them on the balance, but 20 grams, 30 grams, 40 grams, they don't need that. They don't need an analytical balance for that purpose, right? So there is a place for everything. So what they would need is something that would go much heavier. We're talking like 100 pounds, 200 pounds. So these precision balances are going to be maybe bigger, maybe the same footprint, but they are made to give you a greater mass number than an analytical balance. These analytical balances that you're seeing here on the right-hand side of the screen, very often they will cap out at 220 to 240 grams. Once you get to that point, it's kind of over. And that's okay for what we need to do in a laboratory arena, because we don't really work that high. We go really tiny amounts, and very often, we're talking like 1, 2, 3, 4, 5 grams, if I'm lucky, 5 grams. A lot of times it's lower than that. And then there are many times that we go below 1 gram. So we're talking like a half of a gram, 0.5, or a quarter of a gram, which is 0.25. That's really the realm that we're working in. So having a precision balance or a top loader that goes really high doesn't make any sense for us, but it might make sense for someone else depending on what they're using that particular balance for. All right. General rules here, if you look over here to the side, the higher the gram goes on the balance, the lower your sensitivity. And that's another reason that we don't like to go down that realm, because when we measure something in a laboratory environment, we want to make sure that we really are measuring what we think that we're measuring, right? We want to get this down to a science, right? So if I take a scale or a balance, and I have a balance that can measure large numbers, then that sensitivity is not very good. In other words, if I place an object on the top of this balance pan and I get a mass of it, and let's say that I just take my breath and blow on it, I might not see any kind of change on the display screen. Right? I mean, that could be a possibility for me. But if I take these analytical balances and I put something on the scale of the analytical or the balance pan, and then I close the doors, well, there's a reason for that. That's to prevent any type of draft, any type of wind current. So I close these doors because this balance is more sensitive. So if I have one of these doors open and I take my breath and I blow on that object, then I'm going to see that these numbers on the display screen, they're going to bounce around a little bit. And that's because this balance is more sensitive than something like a precision or a top loader. So we are capped at 220, 240. 240-ish, give or take a little bit, is what most of ours are. If I weigh anything greater than 240, what will happen on the display screen is it will say, max, you can't go higher, sorry, nope, you're going to have to do something else. Or it will say something like invalid. I mean, it will give me some kind of nasty message that's on the display screen. And then I'll just kind of grump and quarrel at it, thinking that it's going to hear me and understand me. And then I've got to go figure out what else do I need to do in order to get to that mass if I am using masses that are that heavy. Most of the time when we run into problems here, we're measuring things like beakers that might show up on that balance pan. Beakers, depending on the size, will be pretty heavy, especially when I get to the 250 gram beaker or milliliter beaker or the 400 milliliter beaker. Those typically will set the scale over its capacity, and I get these invalid or I get these maximum error messages that happen on the screen, and that is why. All right. So just to prove, listen, yeah, there are maybe areas in a laboratory that need pounds and, kilograms of material. And those are more on the manufacturing side of the house. But here in a testing laboratory, we're using these analytical balances. So what I would say here is that this, for what we do, is going to be the manufacturing side, and this is going to be for the testing side. Once those things are manufactured and made, we often have to test those to make sure they're quality. So this is where we use those balances. However, this is not the only option. We do have what we call micro balances, and we have ultra micro balances, right? So these micro balances go even lower. Folks, look at this. I mean, a micro balance goes to 0.0000. This is where we would normally stop for an analytical, but there's 2 more digits after that. 00 or 01. So 6 digits after the decimal point. That's what we call a micro balance. We do have these. We have 2 of these in the Chemtech laboratory spaces. This is something that allows us to go super, super tiny. They have specific purposes here. It's somewhat overkill for what we do a lot of times, but we at least have the capability to do it if we need to go down that rabbit hole. So that's why we only have two. That is it. The majority of their balances are 4 digits. Then we have things that are ultra micro balances, and those go to an extra digit, and you will find 7 digits here on that display screen. So what you're seeing here on the picture is a micro balance, but it's the ultra version. This has 7 or more decimal places that it can provide you as a readout. So why would we use something this sensitive, right? Why would we need something that will give us such a small number and maybe, cross our fingers, hope that it is correct and that it's accurate and that it's that sensitive? Well, there are certain tests that we do in a laboratory that's actually not uncommon depending on the field that I'm working with. And you're going to see those tests listed, at least some of them, here at the bottom. So used for what we call trace analysis, and trace means very little of, right? So if I'm trying to measure and get a mass of something, and I know that it's going to be very, 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 very tiny, then a ultra micro balance would be appropriate for that. If I'm using calibration work, so let's say that I want to make sure that glassware is calibrated, because that does need to be calibrated as well, right? So I'm making sure that it's made the proper way, it's delivering the proper amount. So a micro balance could be used to give me that delivery from those pieces of glassware or other instrumentation that I'm using. And the further I go number-wise, the better idea I get if it's calibrated or not. We also have these tests called ashing and incineration. This is literally kind of taking some stuff and then just burning the bejesus out of it. And then we put it in a really hot oven, we incinerate it, and then after that, we look at the residue, what's left over. We hope that nothing's left over, because that's contamination most of the time. And then sometimes what is left over is super, 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 super tiny. So we need a micro balance, or we need an ultra micro balance, in order to make sure that we are reporting those measurements as accurately as possible. And then finally, just drying laboratory tests. This is the idea that maybe something has water that is lingering behind, and we want to get rid of that water. We want to make sure that it's completely dry. So very often we have to go super, super low with those measurements if we want to ensure that all of that water really is truly gone out of that material. So drying, ashing, incineration, you're actually going to do with us in our laboratory in this course and throughout our program. The trace analysis kind of thing, we don't dabble that far into it needing 6 or 7 decimal places. The 4 decimal places with the trace analysis is okay for what we do with our purpose, and it gets the same idea across. All right, so we do have 2 microbalances in our lab. We have them in a different location. They're not in our main working lab, but they're in a different part of our laboratory areas. And then finally, the other type of balance I want to talk about is something that looks like this. These balances are typically made to go micro way, right? So we're looking at 6 digits or 7 digits with these display readouts very often. And then up here at the very top, you see this kind of weird contraption that is present there. And that contraption is meant to deliver a certain amount of substance for you. So I want you to think of these as like automated delivery devices. So what would happen is that I would put a container or something down here at the very bottom, something to collect that volume with, especially if I'm using a liquid. And then this instrument piece on top of the balance is going to be connected to some type of container or vessel that's got liquids on the inside of it, right? So this is going to deliver, and it's going to squirt a little bit of solution down into those pans or those containers for you. And you go in and you tell it, listen, I want you to weigh out 5 grams of material. and then it will, and then you get 5 grams of material. So that saves you a little bit of time and effort and energy in order to get these exact measurements that something like this automation delivery device can provide to you. So once again, we don't have any of these in our lab areas. Again, it's overkill. Think of taxpayer money. We want to save that whenever possible. But these options are out there, and these are great if you're doing a test over and over and over and over and over. We call this repeatability, right? So if you are doing the same test day in, day out, hour after hour after hour, no one wants to be bothered with measuring out 2.5783 grams of material, right? So this machine that's coupled to the balance will do that process for you, save you some time and effort and some headaches. All right. Balance receipt printers are also a thing. So here you actually see a awful picture of one of our balances in our lab, but over here to the side, you're going to see a receipt printer that is connected to our balances. We do this for a couple of reasons. Number one, don't lie, don't lie, don't lie, don't lie. Don't lie to me about measurements that you're making in a lab, right? And that's the purpose of a receipt printer, because believe it or not, in the past, we've had students to pretend like they've done labs and that they've weighed out certain things, or they've made products and they've weighed those products and they pretend like that number is something that it's not. And then they write down the number on the data sheet and they know that I have no clue if it's true or not. So this prevents the liebacks that happen in our lab. And we see those time and time again, not often, but at least once every other semester or every 2-3 semesters, I'll find someone in a laboratory arena that's lying about data, thinking that we're going to fall for it. So we put a stop to a lot of this by requiring receipt printers being installed onto our balances. Now, once again, this is not a waste of taxpayer money, because these receipt printers are also in industry. All right. So I'm going to find these receipt printers in environmental labs. I'm going to find them in pharmaceutical labs, cosmetic labs. If they want to make sure that their employees are really measuring out what they're supposed to measure out, then receipt printers are a great way to show proof. And that's what this is all about. So we say proof in layman's terms, but if you're talking about maybe a laboratory environment, they like to sound really smart and they like to use really big words that basically mean something totally understandable. And then this is what we call traceability. It gives us traceability in a laboratory. So that means that I don't have to be there with you. You're going to measure something out onto the balance. You're going to write that number down, and then you're going to print that number off. That receipt printer will give you a nice receipt ticket that you can rip off of that printer, and then you can tape it onto a data sheet or tape it inside of a laboratory notebook, and that is what we call traceability, because I can go back to that receipt printer and I can say, no, look, you've got proof in the pudding. This is exactly what you weighed out and you didn't lie, so good job, pat on the back. So traceability, that's what that word means. Again, a little bit of common sense. We just use something else to describe the same thing. So we make ourselves sound smart by using big terms like that. All right, so balances, however, if you don't want receipt printers, can also be connected to something that we call a laboratory information management system, or LIMS. LIMS. I actually left off the information part there when I described what that abbreviation stood for. So, Laboratory Information Management System. What this is that very often they don't want to be bothered with these printers. There's a little bit of upkeep with them, right? You've got these receipt papers that you got to keep track of. You've got the ink kind of that you got to keep track of. If you're using thermal, then this thermal paper, if it gets hot or if it gets stored in an area that's kind of humid, then the thermal paper begins to kind of do weird things. So maybe, just maybe, they don't like the idea of a receipt printer, and LIMS will take care of that. So I often call LIMS something like a big brother. I'm going to explain what that means in just a second, but everything that you do, in this case at the balance, will be registered and recorded. And all of that activity goes into what we call the LIMS system, Laboratory Information Management System. It's basically a whole like big computer system networked that's connected to everything in all the laboratories, and anyone with a push of a button can go into that computer software and take a look at what you did on the day and the time that you were working or supposed to be working. And they can keep track of every move that you make throughout the normal process of a work day. We do have these receipt printers connected to many of our balances, not all of them, but we have a total of 14 because we have 14 analytical balances, and they run us about $750 a piece. So we've invested a little more than $10,000 in receipt printers here for the analytical balances. Some work great because they're newer, and some are awful because they're older. And they do mess up, and they get age, and they just don't work anymore, and we got to trash them. So you will see analytical balances that won't have printers on them. And most of the time, these are the older balances that we have, or in rooms where we don't need the receipt printers, because very often what we do in those rooms, we don't need it for that purpose. So they're just not connected to a printer because of that. As far as the LIMS go, that might be surprising to you, right? I mean, here we've got a LIMS system, Laboratory Information Management System. If you've not picked up on it yet, whenever I repeat something over and over and over and over and over and over and over, that probably means that you're going to see it again at some point in time, right? So you know good and well, there's going to be a question, whether it's online or whether it's on a test, and it's going to say, what does the abbreviation for LIMS mean? I mean, you know it because I've just said it 3 or 4 times already. So, Laboratory Information Management System. And what you will find in the LIMS system is that everything is connected. So here, what we're talking about are instruments, right? So every single instrument that we use in a laboratory can be connected to the LIMS system, and it will constantly feed data into that software network database. So those instruments will include things like HPLCs and GCs, which you don't know what those are yet, but they also include something simple like a analytical balance. All right. Also, all the analytical data that gets generated from the equipment goes into the LIMS system as well, and that is a automatic process most of the time. So when I go over to the balance and I weigh something on the balance and I get the mass that I actually need, I'm going to hit a button, and that button is like an enter button, and that sends a trigger to go into the LIMS, and the LIMS now has that completely saved with a date and a timestamp and the person who actually did that measurement. So that way an auditor can go back and take a look at this information if needed to see who, when, what, where, how, and what happened. Okay. Also, one of the other things that go into a LIMS system that we might want to talk about right now are the spreadsheets. I know that maybe scares you a little bit. Spreadsheets? Nobody said anything about spreadsheets. Isn't that what accountants do? And the answer is, well, no, not really. Okay. So the spreadsheets that you're going to see, those spreadsheets are basically Excel templates. And those Excel templates are already going to be made for you. The only thing that you have to do is download them, and you just fill them out, right? It's like a form. So you take the raw data, and that raw data gets entered into a spreadsheet that's already made for you, and that spreadsheet will actually do all of the calculations for you. And that makes everybody happy, right? It makes the company happy because they know that all the math is taken care of. No one's going to mess anything up by calculators and not knowing how to solve equations. And that makes you happy because the only thing that you have to do is just plug in the number that you generate in a laboratory facility. So all of those spreadsheets, once they are saved, you can upload those into the LIMS system as well, so that way a company can keep track of it. Other areas that the LIM will focus on, I can just briefly talk about here, is the lab organization. So what that means is that managers and other people that are not doing the test but want to look at the tests that are getting completed can go into the LIM system and they can track the sample, and it will show them what has been done to that sample and what is left over for that sample, especially if there's multiple tests that need to be done on something that has been submitted to a laboratory. Different levels of validation. Well, this is kind of the double checkers, right? That's what validation is. So once you do something, how did you make sure that what you generated was actually legit, right? Did you do anything else to prove that your data is quality data? And that's the purpose of a different class that we offer in our program, but that's what we call validation. You are making sure that your data is valid, right? You just didn't do the test one time and be like, here's my number, and then go on, because that's not good enough for a laboratory environment. Next up here is that the clients, which are the people that have hired the laboratory to do a certain job, those clients pay that company to do tests for them, right? And clients can log into the LIMS system, and in real time, they can track what is getting done. So if they've submitted a laboratory sample, then someone from the outside can go into the LIMS with a username and password, and they can view all of the test results that are getting generated in real time, and they can keep track and be like, hey, listen, there's this one test and it's just kind of been out there and it's not completed and it's been out there for 2 weeks. What's going on with it, right? So they can call this company up and say, you know, lab, you got to get it together a little bit because you're slacking with your employees. And then they can follow up on those tests and make sure that they get completed. And then finally, results and communication to your clients. So what will happen is that the LIMS system, once everything is double checked and which managers sign off and those types of things, it will automatically generate a formal lab report. And those lab reports will be sent to the clients who have paid for that service. And this puts a little bit of automation to that process. So that is what we term LIMS. What does it stand for again? All right, so in the next video, we'll pick up from here and we'll continue with this discussion of an analytical balance.